How are you, everybody who is watching this video? I would like to take this opportunity to welcome you into a very interesting and new topic that's called the decoders and 433 megahertz RF receiver. And my name is Olenjolain. It's the first time to meet me. I'm very happy to have you. And this is just a continuation of the contents that we've been creating for the module called Electronics Communication Laboratory. We are teaching our students physically at Dar es Salaam Institute of Technology. And these are the students who are actually pursuing ordinary diploma in Electronics and Telecommunication Engineering, the third year, or we call them NTA Level 60. Also, we are teaching NTA Level 7 students who are students pursuing Bachelor in Electronics and Telecommunication Engineering, so first year undergraduate students. So I have a very important contents. Actually, we'll be building up your concepts, so your mindset about the decoders, and actually that we are going to study, or we are going to start particularly a pair of the decoder that we've been studying its own encoder. But remember that the main objective, we are trying to build the concepts into the minds of the students in order for you to make or to build your own transmitter, wireless transmitter, and also to build your own wireless receiver. So it's a new topic, so we don't have a quick review. We are going straight forward to the concept in order to move on. One thing which I want to tell you that in this lecture, we are planning to cover a lot of materials within a short time. So you should concentrate and should focus and you should actually ask questions. Because we are trying to run out of time. So that's why that we have to cover a number of material within this. For instance, in case of the encoder, we taught you the concepts of encoder, and then we taught you the particular encoder. So we had the 2 workshops or 2 lectures for the encoder. But for the decoder, we are going to have only 1 lecture that's combining the concepts for the concepts, introductory concept for the decoder, and also the particular decoder, which is Ht12D Decoder. So let us go to the business. I think that you are ready, and let me appreciate some physical students, including some physical students who are in this class. How are you, students? How are you, engineering students? Dennis, can you move the other sides? Can you come, please? Dennis, sit there, nearby Nema. Dennis. Okay, so say decoders and 433 megahertz RF receiver. I can say it with power. What? So it's better even those who have kept you quiet. Eh? Decoders and the 433 megahertz RF receiver. What, students? Say decoders. Good. So the fundamental question that we like to answer is, what is decoder? So what is a decoder, or what is decoder? So simply, we can define a decoder according to the definitions that we have concerning about encoder. A decoder is the combinational logic circuit that we've discussed before. Is a combinational logic circuit. So this is the combinational logic circuit. Combinational logic circuit that conveys unique, sit there, the 3rd row on your left hand side, unique binary coded information. Binary coded information. Binary coded information into a set of outputs. This is the simple definition of decoder. I said sit there. Sit there. So a decoder, this is the combinational logic circuit that conveys certain unique binary coded information into a set of of outputs. So actually a decoder needs something which has been encoded. So a decoder is actually encoding the information which had been encoded by the encoder. But again, itself will be just taking in the binary coded information and then convey that unique binary coded information into a set of outputs. Say a set of outputs. Say a set of outputs. So what do you understand about a set of outputs? Simply, it means that these combinational logic circuits, we expect it to get more than one output. That's the meaning of a set. Whenever you hear that we have a set of cooking utensil, or a set of maybe shoes, or a set of maybe a set of what? A set of children, or a set of women, a set of men. So it means that whenever we talk about a set, we talk about more than one element. Are we together? Why? Remember, for the case of the encoder, it does not give us a set of outputs. It actually receives the binary information and give out the coded information, which is unique. So this is the one way that we can define the word decoder. But also, there are some other sources that define the decoder by using another style. So the decoder is a type of combinational logic circuit. The types of combinational logic circuit. The types of combinational logic circuit that conveys the binary coded information, from the encode inputs to the maximum of 2 power n unique outputs. So this is another style that we define the word decoder. Class A decoder. Class A decoder. Okay. So this is a combinational logic circuit that conveys the binary coded information from encode inputs to the maximum of 2 power n unique outputs. So from encode input to 2 power n outputs. What does it mean? So between n and 2 power n, which is largest? Compare n and 2 power n. 2 power n. So in case of the encoder, it was actually the input was 2 power n to n, right? So in any encoder system, we expect to have a large number of binary inputs rather than binary outputs. Are we together? But for the decoder, it's vice versa of vice versa of encoder. Okay? Yeah. Then, if this is the case from this formula, so we say that the general formula, engineering is all about formula. The general formula of decoder, is n to 2 power n. So n, whenever we talk about n, so remember that for this case, you're talking about inputs. Whenever I talk about 2 power n, for this case, you're talking about outputs. However, that sometimes the formula might deviate. For instance, Ht12, so we had, actually we had 4 inputs and single output, right? But this is the general formula. But some, we have special encoders and special decoders. For instance, you have priority encoders and also you have priority decoders. So those are the special. But when you talk about general, it means that this is the general formula that used to design and make decoders. Are we together? But sometimes you might have special purpose, or the decoders which have been manufactured for the particular purpose. So for that case, if that's the formula now, we say that, example, if you start when the value of n is 0, you know that you want to have any decoder, right? When n is equal to 0, so n is equal to 0, then dash 2, then dash 2 power 0. Then what are we going to have? 0 to 2 power 1. So we don't have inputs. So we don't expect to have output. So that's not a decoder. Right? So if the number of inputs is 0, we don't have a decoder. That's simple like that. So remember that we learned these things or these concepts also when we've been learning what is the encoder. Okay? So when n, so the condition for this formula is when n is greater than or equal to what? 1. And we learned mathematics, and this is one of the applications of mathematics. So it means you expect to have at least one input of the decoder. Otherwise, we don't have a decoder, right? Are we together? Are we together? Class, are we together? When n is equal to 1, it means that you have a single single input. So what will be the number of inputs? The number of inputs will be 1. The number of outputs will be 2 power 1. So simply mean that this one, we call it a 1, 2, 2 decoder. So it's a decoder which has one input and 2 outputs. Right? Simple like that, because as electronics and telecommunication engineer, to remember formula is very simple for you. When n is equal to 2, so what does it mean? I shall mean that, so this the n is equal to 2. So this is the number 40, so we have 2 inputs. You have a decoder with 2 inputs. Then, how many outputs are we going to have? We have 2 power 2. So simply, this one we call it, it's a decoder with 2 inputs and 4 outputs. Class, are we together? Class, you are quiet. What does it mean? Are we together with these examples of decoders? Yeah, so say yes or no. So I might know that how to help you. So they say the general example of decoder, we say that when n is equal to 3. So for that case, you are going to have 3 dash 2 power 3 decoder. For that case, you're going to have 3, then 2, what? 80 decoder. So you're going to have, for this case, we can have a decoder with 3 inputs and 8 outputs. Pasco, no, not Pasco. Omachi, go and refresh yourself. Go there, quickly. Go and refresh yourself. Dress yourself very well. Then come back to the class, because we still have a long journey. So if right now you are kind of tired, then the business. Dominic, what are you doing? That's not your right position. Your right position is there, nearby Anastasia. Okay, so you can have a number of examples. When n is equal to 4. So for this case, we are going to have 4 inputs of 40 of the decoder. According to our formula, we are going to have 4, then dash, then 2 power 4. This means that we are going to have 4 by by 16 decoder. So a decoder which has 4 inputs with 16 outputs. When you talk about inputs and outputs, so it means that you have to understand that we are actually talking about we are actually talking about the data pins. So we are not talking about address pins for this case. Well, so if that's the case, then we are very interested to know about the general block diagram. What the general block diagram? These are the engineering information that we need. General block diagram. General block diagram. General block diagram of 40 of encoder. General block diagram of encoder. So let me clean here. What the first block that you think we'll start with? Raphael, the first block. A, power supply. So the first block, we are just writing power supply. Good try, Joshua, the first block. DC, power supply, Good try, Jessica, what the first block? DC power supply. Good try, Guess Ronika, what the first block? Speak loudly. A, DC power supply. Okay, good try, Input C. Input. Input block. Okay, thank you. Then, Adamuti. DC power supply. DC power supply. Fatuma Makame. DC power supply. Zuena Masebo. Bundala. So, you've just mentioned in DC power supply, DC power supply, then you ended there. So class is not called the DC power supply. It's called the DC power supply unit. So DC power supply unit. DC power supply unit. Then for this case, input unit. Then another block that we expect to have. We have address. Are you discussing DC power supply unit or what are you discussing? Address unit. And then another block, that is the control unit. We have decoder unit. Then we have another block. This block we have what? Output. Then the DC power supply unit will power the decoder unit, because we don't know the source of the input binary codes. We might provide power, but for this case, okay, yes, you might provide power, depends the source of the input. Make sure that, how many are you there? When you become 5, you'll get it. So check who is not out, who is not in, and then call him or her. Okay? So simply, this is the, just see the general block diagrams of 40 of the decoder. General block diagram of decoder. So the structure of the general block diagrams of decoder, if you analyze figure 1, if you analyze figure 1 and the previous figure, I think that was figure 1 also in workshop 6, you can find that they look similar. Nura, I told you that how many are you there? 1. So check who is not in this class and call him to come to the class. Once you become 5, you get in. So you learn that how many latecomers do we have in this class. Get in. Go there. Decoder. Oh, sorry. Thank you. So I've made a mistake, and always Alawi is very good in correcting the errors that you are doing in the class. Alawi, the one of the students who is very good. Others, they just correct themselves and then they keep quiet. You have to make sure that you do correction of what you have written, because some of the students, sometimes, you just find that unfortunately they are just copying. They don't even think about what has been written on the blackboard and what they have to copy. So, general block diagrams of decoder. Say decoder. Say decoder. Okay, so this is the C power supply unit, and this is input unit, this is address unit, this is the output unit, and this is the decoder unit. So the address unit will be acting as the input to the decoder unit. However, that the address unit is a part of the decoder integrated circuit. But what actual will do is actual will check the address of the incoming information. Because for instance, if you say that we have a particular encoder that has encoded a particular information, it will provide what? The address, right? And that address will be well defined in this decoder. So the decoder is actually changed. Just like if you want to send maybe an invitation later, or maybe a friend later, or an application later to the particular maybe institutions or the particular friend. Elias Emmanuel and Eliakim, what's going on? Huh? What's going on? You have another class there. So, that's why we say that this is the address unit, to check the address of incoming. When we'll be learning about particular decoder, you will see that how these decoders will actually isolate the particular information. Each decoder unit has its own addresses, and also each encoder unit has its own addresses. But we say that the address of the encoder must be well understood by the address of OT of the decoder. So address is very important when it comes to the OT, the encoder, and the decoder. So you might understand, or you might prefer the general block diagrams of wired and the wireless digital communication system. We had the channel encoder, and also we have what? Source what? Encoder, right? And as for the part of the reception, we had what? Source decoder and channel what? Decoder. So that's why we are teaching you the concepts of encoder and what? And the decoder. So that's all, because this is the part of digital electronics. Let us focus into electronics communication laboratory. So if that's the case, now let us just learn one of the decoder that's called the Ht12D decoder. Ht12D decoder. Okay? Say Ht12D decoder. Again, Johanna yourself. Say Ht12D decoder. Loudly again. 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 Okay, all the class. Say Ht12D decoder. Okay, so this will be question number 2 for this lecture. What is Ht12D decoder? So we say that the Ht12D decoder is the combinational logic circuit. Is a combinational logic circuit. This is the combinational logic circuit that receives the binary coded information receive the binary coded information. So row it's what? It's a single input data pin, and the decode it to give output. Row it's for hey, go out. Who told you to get in? There's a security in this class. So you took advantage of your Sierra. So you say Sierra, because you've been there. So Sierra, take a cup of her. So you are 3, just find 2. Pardon? It depends the source of your input. But for the case that it depends. If you have maybe a digital sensor, no, not a digital sensor actually. When it comes for the decoder, yes, the input, we expect it from the transmitter. Okay? So this input, it might be even just, because when we talk about input unit, we talk about the part of the decoder IC for this case. But in case of the coded information, actually expect it from the another source, which is always used to be another system. Are we together? Huh? So you say that the Ht12D decoder is a combination logic circuit that receives the binary coded information. Through its single input data pin and decode it to give out through its 4 output pin. So this is how we define our Ht12D decoder. So from this definition, you might find that we say that the Ht12D decoder uses the so instead of uses the I said excluding Adam. You, Mugisha. Go out. Excluding Adam. You are still 4. Look the other one. Are you joining them? Put 12. Okay. So Adam was inside the class. Who is that intelligent? Abdul Majid, yeah? So the Ht12D decoder uses serial in, parallel out. Serial in, parallel out. Communication protocol. Say serial in, parallel out. So what are you doing there outside, please? Hey, check who is not in the class and call him or her. Mageni, you are dressing yourself, eh? Huh? That's the place for dressing yourself. I'm not kidding. Get it? So what does it mean? We say that if this is Ht12D decoder, what do we expect? We expect it to have a single input and having 4. Hello, look on the blackboard, please. Hello, look on the blackboard. So we remember that the Ht12E encoder, it actually can receive 4 different binary inputs from different sources. That's what you have to remember. So, for this case, or in case of the Ht12E encoder, so the communication protocol used is called the parallel in, serial out. Parallel in, serial out. Just have your seat here. Parallel in, serial out. Hey. Parallel in, serial out. That is what you use, the parallel in, serial out. So for this case, for instance, this is Ht12D decoder because it can receive 1 binary information. It can receive 2 binary information. It can receive 3 binary information. It can receive 4 binary information. And then provide all of those binary information in its own bit or its own output bit. So for instance, we have 4 bits. Let's say that you have, in case that maybe you have 1 bit from OT, from there, maybe from a decoder, from a Ht12E encoder. So this bit, it depends. If it has been given out or it has been actual, the input has been connected to AD8, then this bit, we expect it to suppose that this one will call it to AD8, and this one will call it to AD9, or this is AD11, this is AD9, no, AD10, this is AD9, this is AD8. So if this bit has been given, or it has been supplied to the encoder at the pin, at the first data pin that's called AD8, we expect that bit to be given out in AD8. So this is in case that the only 1 binary coded information received from another distant transmitter where there is the encoder. Are you together? Are you together, class? I say stop writing, stop drawing, listen and watch. Again, we may supply, for the case of the encoder, we may supply more than 1 input. Maybe we connect the another inputs at AD9. So once you connect another input at AD9, then this bit now will be here. This is for AD8. It will be given out from AD8. But remember that this is coded, this is uncoded. Right? This has been encrypted, this is not unencrypted. So for you, you just see it's number 1 and number 1. But this number 1 has unique address in airspace. Or in airspace. Okay? So this is a binary number including its unique address and also the encryption. Are we together? Then we say that we have 89. So 89, then we are going to have another bit. So the bits will be supplied in series. So first bit from 88, second bit from 89. So the output we expect it to get it from 89. But this is a information signal or encoded signal. This is coded signal. If, for instance, let's say that this is here at this point we have 0, so we expect at 89 of the decoder to have a bit of 0. So you see that bit 1 and bit 0, these are parallel. While bit 1, 0, and 1, we have supplied them into a Ht12D decoder in series. Are we together? No. So then she said no. Stop. Okay. So what I was explaining, let me repeat because Dennis and some other students say that they did not understand. Get through. Let me repeat. Dennis and other students, this is the general structure of HT. Nema. This is a general structure of Ht12D decoder. Say Ht12D decoder. Again, say it loudly to write in your mind. Good. So, according to the definition, we say that it receives what is the binary coded information through its single what is input data pin. So this is the single input data pin. Go. Input data pin. Okay? We'll draw the physical appearance of it because it has 18 pins. We are going to draw. But just I want to teach you this concept communication protocol that we call SIPO, CISO, whatever, because we have 4 of them. And we are using them in encoder and decoder. Sometimes we are using them in case of the counters. So it depends on what you are designing in digital electronics. So it receives a single binary input and also gives out that single binary input. It means that binary coded information. It gives us through what it gives out output through 4 output what pins. Are we together? So if you want to write the formula, first of all, of Ht12 decoder itself, we say that 1, 2, 4. 1 represents what single input. 4 represents what 4 outputs. So it can provide output through 4 data pins. You can connect or you can use it when you want to use, let's say, 4 sensors. So it can actually give out the output signal to the maybe microcontroller, to the microprocessor, to the other logic circuits through 4 data of 4 output pins. So that's what we have learned from the definition, and that's what I've taught you. But right now, I want to teach you the principle, what the communication protocol used in this integrated circuit. That's what I was explaining to you. And we say that itself is using what? Serial input, parallel output. Say serial input, parallel output. You learn about serial input, parallel output, serial output, parallel input. We learn them in details in the next module that called digital electronics, because at the moment when you're going to learn a lot about sequential circuit. Are we together? So for instance, right now, I just want to introduce it to you. Say again, serial input, parallel output. Again, say serial input, parallel output. So these are the abbreviations of serial input, parallel output. Right? So remember that these input data pins of the Ht12 decoder can receive either single information, single coded information, or 2 coded information, or 3 binary coded information, or 4 binary coded information. Where are those information have been coded? Well, in Ht12 E encoder. That's why we say that they are working as what? Pair. Are we together? Are we together? Yes. Oh yeah. Hurry up, please. So, for that case, listen. In case of the encoder, this is Ht12E that we have covered. We have AD8, we have AD9, we have AD10, we have AD11. So the encoder, which is working as a pair with this decoder, also it has 4 inputs. So it can receive 4 digital information and give us a single digital information. Can I have it? Give me, please. Hurry up. Yes, that is Engineer Kanke. Kesha. Do you see your sister nowadays? She's the expert there. That's why she shifted from here to there. Okay. So, suppose that we have just see, means that the encoder received only a single binary input. Say single binary input. So when the Ht12E encoder receives only a single binary input, it encodes it and gives the output and transmits through the 433 megahertz RF transmit. That's the one of the simple transmitter. It doesn't mean that this encoder and decoder works with only 433 megahertz transmitter receiver. No, they can work with any wireless transmitter and any wireless receiver. So you should not claim that this pair of encoder and decoder should be used only or should be used with 433 megahertz RF receiver or transmitter. No. Right? You may use it, even it, you may use it with what we call the ESP. ESP, we call ESP Wi-Fi modules. Also, you have some other transmitters and the receivers, which actually can go up to 500 meters in open space. But for that case, you need also to program that transmitter modules or that RF receiver module. We call it NRF transceiver. Okay, so suppose that the decoder received a single input from 88, right? It will be coded and given out at D out or pin number 17, right? Then it will be given out to the 433 megahertz RF transmitter, right? Then the information will be propagated. And the RF receiver antenna will actually receive the signal and convert to electrical signal, right? And as after that, for that case, it means that in this input data pins of Ht12D decoder will be receiving, for instance, a coded information that is binary bit number 1. Then it decodes, right? First of all, it does not decode. It has to check whether this BT1 is come from Ht12E encoder. If this BT1 comes from Ht12E encoder, then it decodes. If it's not come from Ht12E encoder, it actual, we call it ignore. Are we together? Are we together? Actual result, it discard. In dictionary, use the word discard. Say discard. Say discard. So if you have a binary bit number 1 which is coded, we expect to have uncoded or unencrypted binary bit number 1 at the one of the input or AD8 at the output pin of a Ht12D decoder. So if you have one binary coded Latifa, go and dress yourself. If you have one binary coded information from a Ht12E encoder, then there is no serial parallel and there is no serial input and parallel output because the input is 1. Are we together? Okay. Suppose that again we added another input at where maybe at AD11, right? Because for our encoder we just use 2 pull-up resistor network, right? One we connected at AD9, the other one is connected at AD11, right? Suppose that the binary bit from that source, maybe from the digital sensor, it's 0, right? So for that case, then remember that we had the 1 from AD8, and then we are going to have 0. So 1 and 0 will be series. So it means actually be supplied through into the encoder as a series of bits, series of binary coded information. Are we together? Are we together? Then this 0 will be decoded within this decoder, right? And then the output will be given to the pin which corresponding to Ht1240E encoder. So this 0 bit 0 it has been supplied to AD11 of Ht1240E encoder. So it will be given out at AD11 of Ht1240D decoder. Class, are we together? So for this case, we have serial in, right? And at the input of Ht12D decoder, we have parallel. That's the concept just I wanted to tell you. Okay? Suppose also we have the said input. We supplied in AD9, and this one is bit number 1. Then the encoder, you see now Sonia is enjoying the moment. of slumbering. Sonia is the king of slumbering there. That's why he moved it from there. Because he was getting a lot of this. And this is when I was just clapping the hands to him. That he, Sonia, 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 Sonia. So then, we have binary bit number what? 1. At AD what? 9. It's what? Coded. Then the decoder, that's what? Decode. Once it decode, it give what? The output at pin number what? AD 9. So, for this case, you have 1. So, 101, these are the serial. Then 011, or let's say that 101, that is parallel. That's all. Class, are we together? Are we together? Okay. Then maybe we have another input at the encoder part. We don't have decoder without encoder. So that the input, suppose that we supplied in AD10 of Ht12D encoder. Okay? So we have bit what? Bit 0. So this bit 0 will be also supplied as a series of 40 of the bits. Right? Then the Ht12D decoder decode the information and give the output at pin number what? AD10. That's all. It's done. So then pin number what? So these output pins of the decoder, you have to connect it to the actuator, or you may connect to the other control unit, or you may connect to other logical circuits, or you may connect to some other electronic circuits. Hey. Are we together? So this is figure what? That is figure what? Figure 2, eh? Very good. Clap your hand for her. She was in the class. She went out, but she was in the class. This is figure 2. If I could have asked the Dennis, the simple of Ht12D decoder. Class, are we together? So DC power supply unit in short. Then right now, let us discuss about the general block diagram. General block diagram of Ht12D decoder. Emmanuel Elias, please. Call back Eliakimu Matthias. Yes, call back. Washroom. For how long? Okay. So this will be figure 3, but we are going to add some other features, the general block diagrams of 40 of Ht12D decoder. So we are going to have another additional block, separating. With this general block diagrams for the case of Ht12D decoder, so for this case, you are going to have Ht12D decoder. Then at this point, we are going to have another block that we call T. This block, we call it transmission what? Valid transmission unit. Valid transmission unit. So this is an additional block. Class A valid transmission unit. How are you drawing this diagram? Eh? Or you just keep some other blocks in the brain, eh? You know your brain is overloaded. Make sure you draw them. Don't say that, so in that general block diagrams of decoder, I would just add another block. Might get surprised. So this is just a general architecture of what is Ht12D decoder. We have a DC power supply unit. We have a Ht12D decoder unit. We have the input unit. We have the address unit. We have the output unit. We have the value transmission unit. Say value transmission unit. Say value transmission unit. For instance, stop writing. In case of your mobile communication, I believe that you used to receive calls from the numbers that you know, and sometimes from the numbers that you don't know. Right? Right? What do you think, for instance, that you've been called by a caller or by a person who is using number, let's say, 666? Hey. What do you think? Muscle. Free muscle. So will you pick the call or you won't pick the call? You won't pick the call. Why? You don't know who is calling you. Right? What if you've been called by the number that maybe 535? Just 3 digits. Hello, I said stop writing, stop drawing. Stop drawing. Now it's a time to reason. For instance, if you've been called by the number 0759, let's say 721134. This one, you might guess that this is the one of the Tanzanian, but unfortunately, maybe I didn't have his phone number, right? We'll pick up with expectation that you are going to talk with somebody, right? If maybe you've been called by number 100, you know that, okay, this is maybe customer cares that are in Airtel or in Vodacom. You don't have a doubt to pick them, right? But what if, for instance, that you've been called by 5, let's say 1, 2, just 3 digits. And then you've been called several times. What do you think? I think that you are not going to pick that call. Or what if, so this is in case of the call. I'm teaching you about the value transmission unity. I'm not teaching you about calls. I'm teaching you about Omachi. Hey. I'm not teaching about calls. I'm teaching about this value transmission unit. What is function? Or how this decoder works. How does it check? Because it does not decode anything. Okay? Then let us think about messages, because you have these problems in Tanzania. You may receive a message from a known number and may receive a message from the known number. Is it? But for instance, if you receive the message that, I have a project at Dodoma and my uncle is his supervisor, so he's looking for somebody who is actual, good in communications and good in negotiating, and you'll have a good work. So, would you like me to share your number to my uncle? Do you used to reply those messages? No. Why? Why you don't reply those messages? Because you know the target. Right? So if you know the target, we say that you read the message, but you don't show any cooperation. You don't complete the communication. Sometimes, if you're expert in that, right? If you're not an expert, you say, this is the good deal. This is the good, then I will get all my tuition fee within 1 hour. I will get the all tuition fee of 4 years. So let me try, because, try. And as you find that you lost all your tuition, and you, okay. So if that's the case, it means in case that you receive the message, it has been written in Swahili, but you don't deal with it, you have done something called in digital electronics and digital communication, you discard. Say you discard. It means you did not acknowledge or you did not understand the address. So The message is not the problem. The problem is the address of the sender. Class, are we together? So similarly, the value transmission unit is actually responsible to check the incoming binary code. So when the incoming binary codes is come from the encoder, the pair encoder, or the pair encoder of a Ht12D decoder, then the information will be decoded. If the information comes from any other encoder, but not a Ht12E encoder, then the decoder will discard. Class, are we together? If you have a question, you may ask. If you don't have question, then let us move to the features. Features. Say features. Say features. Say features. Eh? 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 Can you check the features of your neighbor? Your neighbor today has amazing features. This is one of the features. Simple harmonic motion. Simple harmonic motion. That's the feature. Features of Ht12D decoder. Say features of Ht12D decoder. Again, say it loudly. Say it until we wake up those who are sleeping. Eh? Again, say it. Who can tell us one of the features if you've understood the definition, the general block diagram? You have a question? You are welcome. So, engineering student Oro has a question. Where is the yesterday friend? Okay. Let us give incoming coded, binary coded information. Actually, it's from the encoder, but through the RF transmitter. Okay? Your expectation is to see this one has been drawn here. Actually, we drew it here because you see the arrow. It's not the output, it's the input. Yes, Ronika, what is Oro's question? What is Oro's question? Huh? Yes, Ronika was not there because she was doing something. Class, this is not an output block. Right? This is input. The issue is not the position of the block. The issue is the direction of what? Arrow. Yes, because actually I know even yourself you say that we have two output there. We have two output. Value transmission unity and output unity. Another question? Happiness? Lugano? Vicky Daddy? You have a question? Sonia? Sure. The first feature about this Ht12D decoder is called that it is 12 bits. Say 12 bits. Say 12 bits. Bundala, where did you go? Bundala, tell us the secret. Where did you go? You spent almost 20. It is 12 bits. Say 12 bits. Say 12 bits. Huh? Are you sure? To be used as pair with Ht12D decoder. So it is 12 bits decoder integrated circuit to be used as pair with Ht12. Oh, sorry, Ht12E encoder. Eliakim Matthias, can you tell us where you come from? You have been there for more than 25 minutes. Tell us the secret. Did you go to take some lunch, some dinner? Huh? Supper? Okay. So it is 12 bits decoder integrated circuits to be used as pair with Ht12E encoder, right? So when you hear 12 bits, in case of the encoder and decoder, listen. When you hear 12, or maybe you hear the number of bits, in case of the encoder and decoder concept, it means that some of the bits are for the data pins or for the input, and also some of the bits are for the OT, for the address pin, or for the address. Listen, whenever you hear that, let's say this is called the 12 bits encoder. Listen. Can Kesha look here, please? You're looking outside there. Okay? Whenever you hear that 12 bits encoder, say 12 bits encoder, we mean that we have 4 input pins and we have 8 address pins. Whenever you hear that, this is called the 12 bits decoder. Say decoder. Say 12 bits decoder. What does it mean? For this case, you have 4 pins for output and we have 8 pins for address. Haha. For this case, digital is beautiful. So whenever we mention number of bits for the encoder, we include the number of inputs and address pins. And for the case of the decoder, it's vice versa. We include the number 40 of address pins and OT, and the, go and dress yourself, go out, and OT, and the output OT pins. So address and the output pins. Okay? Okay, class? So the second feature is say that the Ht12D decoder IC has only one input pin. And then number 3, we say that the Ht12D decoder has, or IC has 4 output pins. 4 output pins. And we've discussed about that. But also we say that the Ht12D decoder has 8 address pins. Has 8 address OT. Has 8 address OT. So it has 8 address pins. Then the 6th feature, number 5. Feature number 5, say that the Ht12D decoder operate with power supply range from 2.4 volts to 12 volts. Then we say typical operating voltage is 5 volts. 5. So how many features you have there? 5. The second one is OT, Ht12 decoder. IC has only one OT, one input, right? Then I had this one that has only 4 OT, output pins. You may use all the output pins. You may use 1 output pin. You may use 2 output pins. You may use any of the 3 output pins. Okay? Okay? Then the 50 feature, we say that this one has operating, or it operates is a power supply range from 2.4 volts up to 12 volt. But the typical operating voltage is 5 volt. Is 5 volt? What the maximum operating power? Huh? You want? What the maximum operating power is? You want to go and take some water? Huh? So you are preparing the bottle? Who gave you? Now the bottle is shared. Yeah? Okay. Go. But wait. Wait. Once I finish features, then you may go. Okay. Then the 60 feature. So, but remember that. Hey, look here. Stop writing. Remember that. Whenever we have a digital integrated circuit which has a wide range of operating power, also, its performance might vary according to the power which has been supplied. For instance, if you supply 4 volts into this Ht12 decoder, then its performance will be differ when you supply 10 volts. Okay? Okay? Yeah. So that's why that we give you a wide range of operating voltage, but we give you the standard one, which we call the typical. And we have covered it, or you have seen it when you've been reading different data sheets. We used to call this is minimum, this is maximum, this is typical. Okay? Then we say that the Ht12D decoder, again, I see, is where? Is commonly used. It's commonly used in RF or in infrared transmission. So the Ht12D decoder IC is commonly used in RF or infrared reception. Infrared reception, yes, infrared reception system. So you use this one, this decoder in what team? The part or to the side of what of the receiver. Then we say the HT, another feature, 12D decoder IC or integrated circuit is available in what team? In 18 dual inline packaging and also in 20 SOP. I gave you a homework to go and find the meaning of SOP. The Ht12. Who found it? Huh? Who found it? So this is a unique feature. Who found the long terms of SOP? Sita, can I have it? Not now. Now it's a time for just a response. Who found it? What are the long terms of the SOP? Because for DIP, I told you the long terms. What are the long terms of DIP? Pardon? Duo package. Duo in package. No, I didn't say that. Boniface, tell us. What are the long terms of DIP? Or DIP? You were in the class that way. Tell us, Collins. Yeah? Duo in package. Yeah. Oro? Long terms of DIP? Huh? Duo in package. Glory?
Hekima, umoja